So number 15, we have a girl coasting down a hill on a sled. So here's the hill, and then she's going to hit this level area. So when she reaches the bottom of the hill, right about here, her VI is 7 meters per second. And then she coasts along the ground, and while she's coasting, kinetic friction is pushing her to the left. And then so somewhere over here, her VF will be equal to 0. So that means that she was accelerated through some distance. So we want to find what is that delta D. That's what we want to find. So we know that she will have experienced an acceleration due to friction. So the free body diagram for her, while she's on this level part, is Fg down, and the weight of her and the sled are given. So there's going to be 645 newtons down, and that also matches the normal force, 645 newtons. And then she moves to the right because of her inertia, and the friction force pushes her back. And we're told that the coefficient of kinetic friction, so mu k, between the sled and the snow is 0.050. So that's going to give us the ability to figure out what is this friction force. So FFk equals mu kFn. So it's going to be 0.050 times 645, which is our normal force. And so for a friction force, we get 32.3 newtons. 32.3 newtons. That's here. And now that is our only force in the x direction. So we're going to sum the forces in the x direction, set them equal to ma. So kinetic friction equals her mass. So now you got to figure out what is the mass. So you know Fg is mg. So 645 equals m times 9.80. So you get the mass. Which is 65.8 kilograms. 65.8 kilograms. And so we'll put in negative 32.3 since the force is to the left equals 65.8 times A. So then A is negative 0.49 meters per second squared. And now we do kinematics to figure out how far she goes. So VI is 7. VF is 0. And A being negative 0.49. Put it in your third equation.